Welcome back. We're writing Little Man Computer in C++, and we've nearly completed all of the main component parts now. But what I wanted to do was just take a little diversion temporarily and actually write a kind of a main program to just bring everything together and test out the sort of real user interaction stuff and just see what that might look like. Just out of interest. So if I have a look at, so we've got all of these parts. We have a computer, we have the abstract input and output streams, and we have a little man. But what I'd like to do is create some sort of little test program to try out writing a small program that uses the real input and output stream, and see what that might look like. So let's create a little program called adder, which is just going to take two numbers provided by the user and put the add them together and put them in the outbox. So we'll need to include our little man here, and then we'll create a main file like so, and inside here we'll create our computer. Well, we'll create first a program like so, which is a vector of ints, and we'll need to work out what that's going to do. And it's going to take an input and then store it somewhere, take another input, and then add the stored value like so, then output that value, and then we're going to then branch back to 0 again, and that's where we're going to store our value. So what this is going to do, we're going to take an input, store it, take another input, add the values together, put the output back, and then repeat essentially infinitely. That will then give us a little peek inside what this might actually look like in real life. This program, this little man computer. So what's the number? 0, 1, 2, 3, 4, 5, and 6. So we'll store that there. We'll take another one. We'll add 6. We'll output, and then we'll branch back. And we've been a little bit, yes, there's a question mark here as to whether we need a halt statement. Given this is running infinitely, I think we can probably do without it. I mean, we may come back to this in a little bit and do something like if the sum of the two numbers is 0, then we'll halt the program. But for now, I think that's fine. Yeah, we'll put a placeholder for the dat there as well, which is effectively looks like a halt statement, but that's going to be continually populated by the value from the input. So we then need a computer, and we need we need to create the input and output streams. So we need to do create a make shared, is it? of a, we'll call them real input. I don't like the name, but we'll call them for now real input stream and a real output stream, like so. These don't exist yet, so this isn't going to quite work. And then we'll create a little man like so, that requires a computer, an input stream, and an output stream. And then we'll need to load the program like so, and then run the program. So that's what our program is going to look like. We then need to create a real input stream, like so. Yes, we've missed some namespaces here. We'll sort that out in a second in the other places. So we'll create a public input stream, which is going to have a next int, which we will need to do something with, and then a real output stream, which is an output stream, like so, and which has add output. Can't remember the exact naming we used. We can just have a look. So add output, constant output. Yeah, okay. So that needs to be const. We'll actually need to populate those with some things in a moment. Let's just make that build. So if we just edit our make file to add in a new target for adder, which takes adder.cpp, depends on lmc.o, and then does the following. Call it adder, and then adder.cpp and lmc.o, and clean the adder as well. We'll see how that works. I suspect there'll be some issues. Yes, we forgot to put the namespaces on things, which is fine. Are that the only requirements? Unused parameter output, and control reaches the end of a non-void function. Yes, yes, of course. So this is where we need to implement things. I think this one's slightly easier, so let's do that one. We can just do this for now, which will let us have hello. Ah, yes, of course. Let's actually include some things. Include IOStream. That deals with that issue. And then we need to do this one now. The question is, how do we get an int from the user? Can we just do this? I don't know, but it's worth a go. Seems to like that. That was a little bit of a a guess there. We'll see what happens if we then run. Oh, isn't that marvelous? There we go. We could really do with something something more sensible in the prompt. Let us say something like this, just to make it easier, and then perhaps we can also do this. That might make it a little bit easier to see what's going on. Input 2, output 7. Oh, very nice. 389. Lovely. 9991. Gets us 0. Excellent. So that works very nicely. Let us just modify our program here to change this to branch if 0, I guess. Is it branch if 0 or do we want branch if positive? Perhaps branch if positive is better. And we'll see what that does. And otherwise we'll hold the program. So we need to change that to 800, which will come back here. Let's make this the address is 7 there, and then we'll have a halt statement and see if halting works. Excellent, let's give that a go. So 1 plus 2, 4 plus 6, 0 plus 0. Oh, failure. That's no, if positive includes 0. So that means that it'll only work for negative values, which we can't get to. Yes, of course. So this needs to be branch of 0 to our halt. So then what we'll need to do is branch to 0 here and then just jump over 1. So that's 0, 1, 2, 3, 4, 5, 6, 7. So we're branching to 7 there, which is our halt. Otherwise we're going to branch back to 0. So and then 8 becomes our memory address there. So this then becomes branch if 0 to 7. That then is like so. So are we doing the right thing? No, that I've just changed that incorrectly. So input, store in memory location 8, input, add memory location 8, output, branch if 0 to 7, which is halt, otherwise branch unconditionally back to the beginning, and this is our dat. So we've got the right number 0, 1, 2, 3, 4, 5, 6. That's 7 is our branch of 0, and 8 is our memory storage. Excellent. So let's see if that does the right thing. 1 and 2 is 3, and 0 is 0, and we finish. Excellent. That's doing exactly the right thing. Very nice. So just a little aside there, just to see our little man computer in action for real with the user input. Very good. Let's store that. That's not how you spell status. Over there. Yes, okay. We also need to add our new nope. Let's git ignore our output, like so. Add in our new file. Lovely. And then add a sample program with real user input and output. There we go. And we can get back to real work next time.